Welcome to a Milak Online tutorial. Before us is this partial differentiation question that says that if v now is a function of x squared plus y squared, now show that x, the partial derivative of v with respect to y minus y, the partial derivative of v to x equals 0. Now you can see that here that v is a function of what? X squared plus y squared. Alright, now for us to differentiate this, let's make u equals x squared plus what? Y squared. And the reason why we are doing this so is because v here now seems to be a function of two variables, okay? And for us to do that, now we have to make x squared plus y squared a sort of one variable, okay? Now, which now implies that the above equation now will now be v equals f of u, okay? Now, this now becomes a sort of function of a function, which means that v is a function of u and u is a function of what? X and y, okay? Now, to that regard, and here is the proof that we need to show that equals to 0. Now, first of all, let us sort out the derivative of v to what? X. Okay? Now, to this end, now this will give us, now since v is a function of u and u is a function of what? X and y. Now, to this end, we need to find the derivative of the function, okay, with respect to the variable, that is x and y. And to that end, we have this, okay? Alright, so where equals to the f over what? The u. Alright, so now the next one now times, now since it's a function of a function, now u with respect to what? X, okay? Since we are looking for the x, with respect to x to this end, so here we have that this will be 2x, because when we differentiate x squared, we have what? 2x. Now, why we do not apply this is because now this is not having a variable of x, so this one becomes 0. Okay, so we end up having where our u is x squared plus y squared then times 2x. Now apply the same method for derivative of the partial derivative of v with to y. So which will give us f u then times 2y, because differentiating y squared we have what? 2y, and this will give us x squared plus y squared then 2y. Now here we've gotten for both for the partial derivative for x and y, okay? Now let us now plug in into this equation if it will give us 0. So here we have that x. Now for our y, where's our y here? We have f prime x squared plus y squared. Okay, for our y, that will be 2y. Okay. Then minus y. Then for x, this is x. X squared plus y squared. Then 2x. All equals to 0. Okay. So here we can see, if we are to open this bracket now, which means x multiply whatever is in bracket. Okay. So here we have, okay, let me do it like this. All squared 2y, then minus y x squared plus y squared 2x all equals to 0. Now looking at here, now we can multiply through. So here you have 2xy f prime x squared plus y squared then minus 2xy x squared plus y squared all equals to 0. Now if you look at this from the left hand side, this expression is the same thing as this expression. So if we probably take the whole of this expression as maybe a, that would be a minus a equals what, 0. So we've shown that x times the partial derivative of v to y minus y times the partial derivative of v to x equals 0. Alright, if you love what I've just done, subscribe to my YouTube channel, follow me on my Facebook so that you'll be notified of all my videos in physics and mathematics. Thank you and God bless you.